Good day once again. This is Ishola Adedeji Michael, and we are continuing our discussion on calculus. Now, we've already introduced the subject of calculus, division of calculus, its meaning, and nature of economic variable. Now, we'll be taking a particular division of calculus in this video. We'll be looking at differential calculus. Now, on that differential calculus, we'll be discussing the definition of differential calculus. We discuss differentiating through the first principle, the constant function rule, the power function rule, the sum and difference of a function, the product function rule, the quotient function rule, the chain rule, the implicit function rule, and the parametric function rule. Now, it is important to know that these are not all just what is under differential calculus. This is the first aspect, this is the first video on differential calculus. In the subsequent video on differential calculus, we'll be talking about the other aspect of what? Of differential calculus. Definition of differential calculus. Now, from our discussion of nature of economic variable, there we draw the graph that looks exactly as this. Now, we realize that economic variables are not static in the sense that their position is disturbed. That is, when look at this variable here, a change in variable x from SO to S1 brings about a change in variable y from SO to what? To Y1. So which means economic variable can what? Move their position from point P to what? To point Q. And from this graph, the coordinate of point P is SO Y1, while the coordinate of point Q is SO plus change in S and YO plus change in Y. Because a move from here to this place creates what we call change in X, and a move from Y0 to Y1 creates what we call change in Y. Why this length here is the what? Is what we call a chord PQ. Now, the popular notation change in S is also known as what? Delta X. Known as delta S is a Greek sign known as delta X. Now, the slope of this curve here, if you show the slope of this curve here, it will be what? Change in y over change in s. That is delta y over delta s, change in y over change in x. Now, this slope simply is also called what? The gradient. And what this simply measure is the rate of change in y as a result of change in x. So what this simply look what is what? The rate of change in y as the result of what? Change in x. Now, when the differentiation now comes in, when we differentiate the function, let's say we have the equation of this chord, PQ, and when we differentiate this chord with respect to what? To x, what we are looking for is what? Is the rate of change in y as a result of change in s, as change in s tends towards 0. That is the rate of change that occurs here as this Q tends to P. As this Q tends to P. That's what we are looking for with differentiation. Let me say it once again. With differentiation, we already have our gradient. Now, the gradient measures the rate of change in y as a result of change in x. But with differentiation, we are attempting to measure the what? The rate of change in y as a result of what? Change in s, as change in s tends to 0. By so, differentiation results in finding what? The derivative of the what? Of the function or the equation given. Now, the derivative is then denoted by the y, the x, the y, the x. This is also the same thing as Greek letter, the y, the x, the y, the x. And the y, the x, by definition, the y, the x equals to the limit of changing y over changing s as what? Changing s tends to 0. Now, this is definition of what? Of calculus. In calculus, we are trying to find the word, the rate of change in y as a result of what? Change in s, as change in s tends to 0. Now, it is the limit of this change in y as change in s tends to 0 that gives us what? The derivative of the equation of this point PQ, of this called PQ. So until you take the limit, everything you are finding is what we call is the gradient. But when you find the limit of the gradients as the what? The independent variable s tends to 0, that is, as the change become what? Non-noticeable. Become non-noticeable, almost 0. That is the what? The derivative of the function. That's the derivative of the function. Don't get it wrong. This notation is the same thing as this. And this notation, we should know that change in y over change in s, this is just what? This is just called what? Derivative quotient. This simply calls what? Derivative quotient, not the derivative of the function. This is not equals to this. Change in y over change in s is not equals to what? The y, the x. It's not equals to the y, the s. For change in y over change in s to be equals to the y, the s, we have to take the limit of change in y over change in s as change in s tends to 0. We have to take the limit for change in y to be equals to change in for change in y over change in s to be equals to what? The y, the s, which is the derivative of the function. Okay. Still go further notationally. Given a function such as y equals to f of x. Now, you can first find what? Derivative quotient or difference quotient. Still the same thing. Change in y over what? Change in s. This is the same as what? The what? Difference quotient or derivative quotient. Now, the derivative of this function will now be limit change in y over change in s as what? Change in s tends to 0, which will now be what? The y, the s. This is the derivative. The y, the x. Now, this derivative is still the same thing as writing what? Y prime. It's the same notation. If you ask this, it's the same thing. And this is also the same thing as what? F prime function of x. So suppose you are given in a equation to find this, they are still the same thing as this. Or you are given to find this, or you are simply asked to find the what? The derivative. The derivative of the given function, they are still asking you to do exactly the same thing. These notations should never be forgotten as far as calculus is concerned, differential calculus is concerned. Now we get to the first principle rule of differentiation. Now, before all the laws or rules of differentiation, at the very inception, the first principle is the rules, like the procedures that is used by the earlier mathematicians in the branches of differential calculus use in differentiating any function given to them. That is the first principle. The first principle of differential can be used to differentiate any function, be it a parametric function, logarithmic function, function of a function, sum of a function, product of a function. The first principle rule can always be applied. That's the first principle of differentiation. But after so many laws have been generalized about differentiation, so differentiation has been made more simpler as we have so many laws that have come to replace the use of first principle. But for the sake of academic intelligence, because many times you go to the examination hall and you are asked differentiate this function using first principle. So a mastery of the first principle is of importance. And also the first principle break down and make us understand what is calculus as has been explained before. So now, the first principle. Let's say we are given a function such as y equals to f of x. Now, if we come to this graph, now we mean y is the what? Independent variable and x is dependent variable. At this particular function, we said that we are interested at this point here. This function, this equation is given at this point here. Now, what happens at this point where there is a change in the what? In s, causing a change in what? In y. So simply what we do here is that we write this function, we write a new function. This first function, we take it as what? Equation 1. Then we have another function with the y plus what? Change in y equals to what? X plus what? Change in x. Now, what am I saying here? Here, x determines y. Now, but at this point, what we have here is what? S0 plus change in s determines what? This new position. That's exactly what is stated here. But as we have already understand, the first thing we are looking for when we are differentiating, we are finding derivative is to find the word. Find the difference quotient. The first thing we are looking for is the word. Is our what? Difference quotient. So simply to get to the point of finding our difference quotient, what we do here is what? We subtract y from both sides. When you subtract y from both sides of this equation, find the difference quotient by first subtract y from both sides of the equation 2. So you have y plus change in y minus y equals to f of s plus change in x minus y. So this will give us change in y equals to what? F of s plus what? Change in x minus y. Name this equation 3. Now let's recall. To still find difference quotient, let's recall that y equals to what? F of x. So therefore, substitute f of s. Substitute f of x for y in equation 3. So we have what? Change in y equals to f of s plus change in x minus f of x. Call this equation 4. Now from equation 4, the next thing you are going to do to find the difference quotient, is the third step to find difference quotient, is to divide all through by change in s. As difference quotient is what? Is change in y over change in s. Difference quotient is also stated as what? As the gradient of the curve. So we have divide through by change in x. So we have change in y over change in s equals to f of s plus change in x minus f of x all over change in x. We can call this equation 5. This is our equation 5. Now, don't forget, this equation 5 is called what? It's called our difference quotient. That's what it is called. It is the gradient. It is the slope. It is the rate of change in y as a result of change in s. It is simply called difference quotient. Now, from the derivation of calculus, said calculus is dy ds, which is equals to limit of what? Change in y over change in s as what? Change in s tends to 0. So in this case, dy ds now equals to limit of f of x plus change in x minus f of x over change in s as what? Change in s tends to 0. This is what the first principle is talking about. This is what the first principle is talking about. So to have a proper understanding of the first principle, you have to first understand that the first thing you are looking for with the first principle is to first find the what? The gradient. That's the first thing you are looking for, is to find the gradient. That is, find the difference equation. And what difference equation? Difference equation is what? Your change in y over change in s. So the procedure, if you are given y equals the function of anything, is first they give you the function of y, like y is a function of x. Now find what happens when there is a change in x. What will that occur? When there is change in s, there will be a change in y. So thereby you express y plus change in y is a function of s plus change in x. So the next step there is what? You make change in y subject to the formula by subtracting y from both sides, and that will then give you change in y equals to x plus change in s, f of s plus change in s minus what? Y. So you already know what y is, which is y is a function of s. So you substitute what you have for y in the what? In the equation, then you have what? Change in y equals to what? F of s plus change in x minus f of x. So since you are looking for the difference quotients, which is change in y over change in s, so the best thing you do there is what? You divide all through by change in x. You divide all through by change in s, and by so doing, when you divide all through by change in s, you have change in y over change in s equals to what? F of s plus change in x minus f of s all divided by what? Change in x. And by so you've already found your difference equation. So the next thing is to find the derivative. So to find the derivative, you already know that what? Derivative, which is dy ds, equals to what? Limit of change in y over change in s as change in s tends to 0. So you simply take the limit of the what? Of your final answer as change in s tends to 0, and that will give us the derivative. So first principle, our understanding of first principle can be broken down into these major 4 steps. First principle can be broken down into these major 4 steps. Given any question to find the derivative through the first principle, these 4 steps gives you a clear answer. And the first steps you do is that, now after giving the function, they give you a function y is equal to f of s. So the first thing you do is what? You express y plus change in y as a function of s plus change in s. Why do we do that? We do this so that we express the new positions of the what? Of the variables we are given. So that's the first step. You express y plus change in y as a function of s plus change in x. So after you must have put in these variables in their new positions, so the next thing you do is what? You subtract y from both sides to find what? Change in y. We need to find our change in y, so we subtract y from both sides. So whatever we've gotten by subtracting y from both sides, So that's what we do. That's what we act on in the step 3, where we what? Divide through by changing s. We divide through by changing s so that we are going to find what? Changing y over changing s, which is what? The difference quotient. Now, after we must have gotten our difference quotient in step 3, so the next thing we do here in the step 4 is what? Is we take the limit of changing y over changing s as changing s tends to 0. That is, we take the limit of our difference quotient as changing s tends to 0. We do this to find the what? The y ds, which is the what? The derivative. Which is derivative we are asked to find, and this will be our final answer. So that's all about derivative through the force principle. I will quickly take us through some set of examples to illustrate derivative through the force principle.